So today I will talk about SU3 representation, and I will divide this lecture into two parts. In the first part I will talk about fundamental triplet of SU3, and I will talk about its weight diagram, right? So this is the first part of my lecture, and in the second lecture I will talk about action of step operator and our step operators, about which I will talk about in the early lecture. So these are our step operators. So I will discuss the action of step operators on fundamental triplet. And I will show it diagrammatically also. This is the second part. So let me talk about first part. The first part is basically the fundamental triplet of SU3. Means first part is fundamental triplet of SU3. It's a fundamental triplet of SU3. So consider fundamental triplet. For this, consider a fundamental triplet that is 1 0 0 0 1 0 and 0 0 1. Thus fundamental triplet is described by eigenvectors. Means thus fundamental triplet, so sorry, in other words I can say that these are the three eigenvectors. These are three eigenvectors of fundamental triplet. Mental triplet. So now consider commuting operators. Now consider commuting operators, that is I3 and Y. So I3 and Y. So I3 is represented by 1 by 2, 0 0 0 minus 1 by 2, it is 0, and it is 0 0 and 0. So this is 1 I3, it represents isospin in 3 by 3 matrix, because in 2 by 2 isospin is represented by this part and rest of will be 0. So this is a way representing isospin in the three-dimensional space, or 3 by 3 matrix form. And as we know that the hypercharge is basically 1 by 3 0 0 0 1 by 3 0 and 0 0 minus 2 by 3. So this is a way to represent the hypercharge. So I have considered these commuting operators, and 1 0 0 0 1 0 and 0 0 1, these are simultaneous eigenstates of, means these 1 0 0 0 1 0 and 0 0 1 are simultaneous eigenstates of I3 and Y. I3 and Y, right? I3 and Y. So in other words I can say that I3 and Y with eigenvalues and the eigenvalues are basically I3 comma y. These are the eigenvalues. So what does it mean? It means that the eigenvalues I3y are, what are these? This is 1 by 2 and 1 by 3. This value means diagonal elements represents it. So 1 by 3 and 1 by 2 and 1 by 3 comma this and this, so means minus 1 by 2 comma 1 by 3 and 0 and minus 2 by 3. So these are the eigenvalues and these are the eigenvectors, right? So let us understand this thing diagrammatically. So as the eigenvalues are 1 by 2 comma 1 by 3, 1 by 2 comma minus 1 by 3 and minus 1 by 3, and it's comma not minus, so it is 0 comma minus 2 by. So these are the three eigenvalues. So that means these are the values of y and these are the values of I3. So that means if we do one thing, say this represents let me do one thing, let me draw it here. Right, so it is say it is I3, it's I3 so it is I3 and it is y, means it is the hypercharge axis and it is the z component of isospin, its component, right? So say it is 1 by 3 and it is minus 1 by 3 and it is 2 by 3 and it is 1 by 3 and it is, which represents minus 2 by 3, and here it is 1 by 2 and it is minus 1 by 2 and it is 1 and it is also 1 minus 1, right? So this point is where it is located. So 1 by 2 and 1 by 3, so it is, say it is 1 by 2 and it is 1 by 3, so this point is represented here. Here the scale will be different, along this axis scale will be little bit different, so this point is this, and similarly another point is located at this point, means it is minus 1 by 2 and 1 by 3, and there is another point that is represented here. So that means this point is what? This point is let me start with, it is 1 by 2 and 1 by 3 and it is minus 1 by 2 and 1 by 3, and it is, for this I3 will be 0, so 0 minus 2 by 3. So these are the representation of all the fundamental triplets, right? So this is the representation of fundamental triplets, and the plot which is shown here, this plot is known as weight diagram, and it's the plot of the y against I3. So thus we can say that the plot of y against I3 is called weight diagram, right? So that's all for this, the first part. Let me talk about the second part, right? And this is the diagrammatic representation of fundamental triplets, right? So this is the diagrammatic representation of fundamental triplets in the form of a weight diagram. So let me talk about the next part. The next part of this lecture is the action of step operator Next I will talk about the action of step operator. The action of step operator I plus minus comma u plus minus and v plus minus on fundamental triplet. On fundamental triplet. This is the second part about which I will talk about in this lecture. This is again very important. So in the earlier lecture I talked about, we have talked about the step operator. So in the earlier lecture we have defined step operators. And what are the step operators? This is the I plus minus, or it is the v plus minus and u plus minus. So these are the step operators about which I talked about. So let us recall some relations. So first is let us consider, or let us now recall. I'm not going to derive this, but let us recall some commutation relations of I3 and Y with these step operators. I'm not going to derive these commutation relations, but I'm directly writing down these here. So first is I3 comma u plus minus. Its commutator relation is basically minus plus 1 by 2 u plus minus. This is one commutation relation. And similarly, the commutation relation of hypercharge with u plus minus, it can be written as, it is equal to plus minus u plus minus. Another commutation relation is that I3 comma I plus minus is equal to plus minus I plus minus, and similarly yi plus minus, its commutation relation can be written as 0, means it is a commutator and they are non-commutator. And similarly another one is I3 comma v plus minus, it is equal to plus minus 1 by 2 v plus minus, and here with the hypercharge what it will be, it is v plus minus, it means the hypercharge and the v plus minus, its commutator relation is equal to plus minus v plus minus. So these are the few standard commutator relations. Now let us understand that what does it mean. So I will try with the first one first of all. So if I consider first one, then what does it mean? So let me consider that I3 u plus minus, its commutator is equal to minus plus 1 by 2 u plus minus. So I can write down this as I3 u plus minus, open this commutator, so it is minus u plus minus I3 is equal to minus plus 1 by 2 u plus minus, right? So what does it mean? It is I3 u plus minus, right? So what does it mean? That is it is equal to u plus minus I3 minus plus 1 by 2 u plus minus. So it can be written as u plus minus can be taken outside, so inside it is I3 minus plus 1 by 2, right? So operating now both sides with the means I3 u plus minus, sorry, yeah, this, and let me operate this with the I comma I3 is equal to, it is u plus minus I3 minus plus 1 by 2, and it is I and I3. So it can be written here because it's a number. So I3 u plus minus I comma I3, it gives us, sorry, it's like this, and it is I3 minus plus 1 by 2 and u plus minus I comma I3. So what this equation will suggest? What this equation will suggest? Let me talk about that. What is the meaning of it? What is the meaning of it? This shows that when I3, sorry, when u plus operates over this, it gives me I3 minus 1 by 2. Means u plus lowers the eigenvalue of I3 by 1 by 2, and u minus raises the eigenvalue of I3 by 1 by 2. That's what will happen. And similarly, if I look at this part similarly, because what u plus will do, it lowers the eigenvalue of I3 by 1 by 2 and raises the value by this, because if it let me rewrite down this part again. Say it is I3 comma u plus, it gives me minus 1 by 2 u plus. What does it mean? That means this u plus lowers the value of I3 by minus 1 by 2, sorry, by 1 by 2, because lower negative sign represents lowering of it, right? Lowered by 1 by 2. And similarly, if I try to look at this, then what this y u plus equal to plus u will do? That means this y, let me explain it on the similar lines, that what this y will do, that's a very important point, that u plus raises the eigenvalue of what? The eigenvalue of y by 1. By 1 means this y plus gives us y plus 1 u plus minus, or sorry, need not to talk about it here, yeah. And similarly I can say that u minus lowers the eigenvalue of by 1, that's the meaning of it. And if I look at this part, then what does it mean? It again means that if I try to look at this part, what does it indicate? It again indicate that this I plus, because it is plus also corresponding to this, so it is raises the eigenvalue of I3 by 1, and I minus lowers the eigenvalue of I3 by 1. But if I look at this part, then what does it mean? It means that this I plus do not change the eigenvalue of y, because this will be 0, and I minus also do not change the eigenvalue of y. That's what we are getting. But if I look at this part, what it indicates? It indicates that this part indicates that v plus raises the eigenvalue of I3 by 1 by 2, and v minus lowers the eigenvalue of I3 by 1 by 2. But if I look at this part, what does it mean? It means that v plus raises the eigenvalue of y by 1, and v minus lowers the eigenvalue of y by 1. That's what we are concluding out of these. If you proceed in this way, and if I recall or remember these commutation relations, I am concluding all these things out of this. So in nutshell, if I summarize all these results, then what should I write down? Let me summarize these all the results. So first is that I summary is that I plus minus induces changes delta y equal to 0 and delta I 3 is equal to plus minus 1. From this, if we talk about this one, right, from this I am concluding this, and u plus minus induces changes. What this will do, u plus minus, it is u plus minus over it is plus minus 1, right? It is equal to plus minus 1, and delta I3 is equal to, for it is minus 1 by 2 or minus plus 1 by 2, and v plus minus induces changes that delta y is equal to plus minus 1 and delta I3 is equal to plus minus half. So that's what we are getting out of it. Clear? So now let me represent all this diagrammatically, that what does it mean. So let me understand it diagrammatically. So let me add it to the next page. Let me, yeah, okay, let me understand it. What does it mean? Yeah, I've summarized it. So let me do one thing. Let us draw a weight diagram first of all. So it is I3 and it is Y. So it is, say it is 1 by 3 and it is 1 by 3 and yeah, it is so it is 2 by 3, it is minus 2 by 3, and here say this point is say minus 1 by 2, sorry, it is so say it is 1 by 2 and it is minus 1 by 2. So these are our points. So since the given points are represented like this, so one point is here and another point will be here and another third point will be here. So let us now see the effect of I plus minus, right? So what I plus minus will do? So what I plus minus will do, for I plus minus, delta y will be 0. Delta y will be 0. So there is no change in it. So let us say, but that means for this line, delta y will remain the same. It will not change. There is no change in y. So that means it will occur along this line. But in addition to it, what is happening? Delta I2 will be equal to I3 is equal to plus minus 1. So this change will also occur. Right? So let me call it as, say, I plus, what I will do? I plus, it is I3 plus 1. That's what will happen. And what I minus will do, it is I3 minus 1. So say, let us consider the values. So say I3 has the two possible values. So I3 is equal to, for this, it is 1 by 2 plus 1 and it is 1 by 2 minus 1. There is one possibility and another is minus 1 by 2 plus 1 and another is minus 1 by 2 minus 1. So it gives minus 3 by 2. So this will not happen. And it gives 3 by 2. This also will not happen, but it will happen. It gives me 1 by 2 and it gives me change for minus 1 by 2. So what does it mean? It means that what I plus will do, I plus is changing minus 1 by 2 to plus 1 so that it will become a this one. So that means this change is represented by I plus, and this change can be done means 1 by 2 minus 1, so that means then we will be at this point. So this is represented by I it is represented by I plus, and let me correct it, yeah, it will not be here, and similarly it will be like this. So it is I minus and it will be I plus. And similarly, what others are doing, other operations, if I try to look at this, what u plus minus will do. So u plus minus, what it is doing, u plus minus, for u plus minus delta y will be, it is plus minus 1, and delta I3 it is equal to minus plus 1 by 2, right? So what does it mean? It can be done with the help of this, right? So what u plus will do, u plus will do this one. This operation can be done with the help of u plus, and this operation can be done with the help of u minus. It can cause these two changes. You can see, as I have seen for this one, because y is also changing, and let me little bit make a difference for it. It is u minus, and similarly when I talk about it, then this is for what? It is v plus, and it is for the v minus. If I keep in mind this operation, right? So this is the pictorial representation of it, right? So what this diagram represents, this diagram represents the action of step operators on, and what are the step operators? The step operators are I plus minus, u plus minus, and v plus minus on fundamental triplet, right? So that's all for this lecture, and in the next lecture I will talk about further more properties of SU3 operators, and how it is used to study various types of particles, right? So thanks for watching this lecture.